Hello friends, welcome to aravalligeoacademy. Today we are going to discuss the next PYQs 35 to 45. We will cover the total 10 PYQs in this video. So this is the first PYQ. Which mineral pair is most indicative of the eclogite facies conditions? Okay, this is asking about the eclogite facies. Number 1, epidote and actinolite. Number 2, sterolite and muscovite. Number 3, omphacite plus garnet. Option 4, biotite and plagioclase. So which one is the indicator of the eclogite facies? Which pair is the indicator? So correct answer of this question is omphacite plus garnet. Okay, we already know omphacite is a pyroxene mineral, and garnet, which garnet actually, this is telling about the pyrope. Okay, pyrope and omphacite is indicator of the eclogite facies. Okay, and eclogite facies means high temperature and high pressure conditions. Okay, next question, which of the following is not division of the Telotremata order in the Brachiopoda? Okay, this is asking Telotremata order in the Brachiopoda. Uh, Terebetulaceae, first option, Terebetulaceae. Number 2, Pentameraceae. Number 3, Spiriferaceae. Okay, Spiriferaceae. Number 4, Rinconellacea. Okay, Rinconellacea. Okay, so which one is not related to the order Telotremata? Okay, this is the order of the Brachiopoda. So which one is not related? So correct answer is the Pentameraceae. Okay, Pentameraceae is the not related to the order Telotremata in the Brachiopoda. Okay, Pentameraceae is not a division of the Telotremata order. It is belong to the order Protremata. Okay, uh, Pentameraceae is the Protremata. Okay, and other are the Telotremata. Okay, so we already know the phylum of Brachiopod. Actually, Brachiopod is a phylum, and class of Brachiopod is the Articulata. Okay, order is Trilodermata, and superfamilies are the Trebetulacea, Spiriferaceae, and Rinconellacea. Okay, these are the superfamilies. Or Pentameraceae, however, belong to the order Protermata, not Telodermata. So correct answer of this question is the Pentameraceae. Okay. Okay. Now next question. What is the value of A in calculation of ACF diagram? So first, mole proportion of Al2O3 plus Na2O plus K2O. Number 2, mole proportion of Al2O3. Number 3, mole proportion Al2O3 minus Na2O plus K2O. Number 4, mole proportion Al2O3 minus Na2O minus K2O. So this is factual question. Okay, in ACF diagram, A represent mole proportion of Al2O3 minus Na2O and K2O. Okay, remember this is a factual question. This is very important for other exams also. Then next question, which of the following conditions are required for recrystallization of the Andalusite and Andalusite into kyanite? So we already know Andalusite and kyanite is the aluminosilicate minerals. Okay. Number 1, so increase in the both pressure and temperature. Number 2, drop in temperature with no change in the pressure. Number 3, drop in the both pressure and temperature. Number 4, increase in pressure with no change in the temperature. So which one is the correct? This is asking Andalusite into kyanite. It means Andalusite convert in the kyanite. So which one is the correct answer? Correct answer is the increase in the pressure with no change in the temperature. Okay, we increase only the pressure. Why? Okay, let's explain through the image. See this image in the y-axis. This is the pressure in the kilobar. okay, and in x-axis this is the temperature range, okay. So we already know there are the three polymorph of the aluminosilicate, andalusite, kyanite and sillimanite, okay. Andalusite actually Andalusite exists in the low temperature pressure condition, and sillimanite stable in the high temperature conditions, okay, and kyanite is stable in the high pressure conditions and low temperature, okay. So when Andalusite recrystallize into kyanite, so which conditions are required? Okay, so high pressure is required only, not temperature. If high temperature is there, then Andalusite recrystallize in the sillimanite. Okay, but when we increase only the pressure, then Andalusite recrystallize into kyanite. Okay, so correct answer of our question is the increase in the pressure with no change in the temperature, then Andalusite recrystallize into kyanite. Clear now? So this is question for you. Focus on this point. Okay, at this point, kyanite, sillimanite, and andalusite coexist. So tell me the temperature and pressure conditions of this point in comment section. This is question for you, and this was many time part of exam also. Okay, so don't ignore this question. Try to drop a comment in the comment section. Next, rock formed by the metamorphism of the original sedimentary rock will show which chemical characters? Rock formed by the metamorphism of original sedimentary rock will show which chemical characters? Number 1, excess of alumina, normative carbon is greater than 10%, K2O greater than Na2O with MgO greater than CaO. Option this is option 3, okay. Very high content of the SiO2 greater than 50%, normative Q. Number 4, CaO is greater than MgO and low Al2O3 and SiO2. So which one is the correct? Okay, so there are the four options: 1, 2 and 3 only, 1 only, second and 4 only, 1 and third only. So which one? So correct answer is 1, 3rd and 4. Okay, CaO greater than MgO and low Al2O3 and SiO2 is not possible in the original sedimentary rock. Okay, so correct answer is the first. 1, 2nd and 3rd is correct. Next question, the norite is characterized by the presence of which of the following minerals? This is asking about the norite. Okay, number 1, quartz and tredimite. Number 2, orthopyroxene and plagioclase. Option 3, wollastonite and diopside. And option 4, nepheline and talc. This is the factual question again, or very easy question. So right answer is the orthopyroxene and plagioclase. Okay, so see this classification. Okay, so we are going to discuss norite first. Okay, so norite is the plagioclase and orthopyroxene rich gabbroic rock. Okay, this one. So remember, in norite, plagioclase and orthopyroxene is dominant, but in gabbro, plagioclase as well as clinopyroxene is dominant. Okay, so what is the difference between gabbro and norite composition? In gabbro, clinopyroxene is dominant, or in norite, OPX is dominant. Okay, and uh, when the both OPX and CPX is dominant, then rock is known as gabbronorite. Okay, this is the Google image. You can also see on the Google. Okay, so remember the composition of norite and composition of gabbro. Okay, next question, which of the following is best describe the scan? So which one is the correct answer? A rock formed from the intersection between the limestone and igneous intrusion. A metamorphic rock formed by the pelagic sediment. A product of the high pressure metamorphism in subduction zone. a high grade rock that lacks significant mineralogical change. So which one is the correct answer? Correct answer is a skarn is a rock formed from the intersection between limestone and igneous intrusion. Okay, so see this Google image. Okay, this is the porphyry stock, or we can say this is the igneous intrusion, or intrusion in the limestone. The host rock is the limestone. Okay, this one is the limestone. So due to this igneous intrusion, due to high temperature, see in this zone, this is the skarn. So skarn is formed at this point. Okay, so skarn form at the intersection between the carbonate rock or igneous intrusion. Okay, so see again the question. Which of the following is best describe the skarn? So skarn is a rock form the intersection between limestone and igneous intrusion. Okay, and we already know skarn is a metamorphic rock. Okay, then next question: I-type granitoid are associated with which of the following? Option A, a pyrogenic setting. Option 2, subduction zone continental margin setting. Option 3, cratonic migmatite complex. Option 4, mid-oceanic ridge. So which one is the correct answer of this question? Correct answer of this question is the subduction zone continental margin setting. Okay, so let's break I type. Okay, I type, it means the parent rock is the igneous. I represent the igneous. Okay, so I type granitoid, the tectonic setting of I type granitoid is the volcanic arc. Okay, and continental arc. We already know volcanic arc and continental arc form in through the at the actually convergent plate boundary settings, and associated with the subduction zone. So remember, subduction zone also associated with the convergent plate boundary. So I type granite associated with the volcanic arc, continental arc, or subduction zone. Number 2, S type granitoid. S represent the parent rock is the sedimentary. Okay, and S type granitoids present at the continental collision zone. Okay, it means where the two continent plates are collide, like the Himalaya. So uh, at this region, S type granitoids will form. Okay, as well as the syn orogenic settings. Okay, so remember this one only, the continental collisional zone. Next one, A-type granitoids. A-type granitoid also known as the anorogenic type. Okay, so this is associated with the intraplate. Okay, intra, it means within the plate, and rift zone form where the plates are diverged to each other. Okay, as well as the post-orogenic or hot spots. Okay, so remember, Malani igneous rhyolite is the best example of the A-type granitoids. Okay. Number 4, M type. M, it means mantle type granitoids. This is tectonic setting is the island arc or early arc magmatic or oceanic crust. Okay, but not important. But remember this one. This one is very important for us. Next question: which of the following granite nomenclature is not related to the genesis? Option A, I type. Option 2, S type. Option 3, C type. Option 4, A type. So which one is not related to the genesis? So correct answer is the C type. We already know I type, S type, and A type granite. Okay, so C type granite is not related to the genesis of granitoids. Okay. Next question: the thermal ionization mass spectrometry is suitable for which one of the following elements? So option A, helium and hydrogen. Option 2, strontium and neodymium. Option 3, nitrogen and oxygen. Option 4, carbon and boron. Okay, so see, focus. Hydrogen and helium, nitrogen and oxygen, carbon and boron, all are gases. Okay, but strontium and neodymium is not gases. Okay, so correct answer is strontium and neodymium. Okay. So thermal ionization mass spectrometry is highly suitable for the analyzing the strontium and neodymium isotopes. Okay, it is widely used in the geochronology. This thermal ionization mass spectrometry used in the geochronology and the isotope geochemistry, particularly for rubidium strontium as well as the samarium neodymium dating method. Okay, thermal ionization mass spectrometry, actually the working principle of this thermal ionization mass spectrometry is the ionized samples and the measures isotope ratio using the thermal evaporation and application isotope analysis. This thermal ionization mass spectrometry used in the isotope analysis for geochronology, like uranium lead dating, strontium neodymium dating, or trace element study, etc. Okay, and geological application of this thermal ionization mass spectrometry is the geochronology. This is used in the geochronology analysis and radiogenic isotope analysis and geoscience. Okay, so thank you so much for watching this video. Try to share with your friends.